Centricity, we have done a solution. The attendance, no light and no battery. Comma. So let me take the attendance then. So many of you are having problem. First of all, this is section A. Okay, section A. This is 01. Roll number 1, enrollment 1.
Present, ma'am.
2, 4, 5,
Yes, ma'am. Number 5.
6,
Roll number 5. Yes, ma'am. Ma'am, roll number 4, present.
7,
6.
6. Okay, 7, 8.
And 4, present 4.
Yeah, present. 8,
Yes, miss, present.
8.
Yes, miss, present.
If I call your enrollment 9, then you please tell 9. Present.
Roll number 8, present, miss.
Enrollment 9, 9, 10,
Present, miss.
10,
Roll number 10. Roll number 10.
11, 12, 13,
12, 12.
12, 13,
12
12.
present.
Okay, 12 present, 14, 15,
15
6,
present, ma'am.
15, 6, 17,
Present, ma'am. 17.
18,
Yes,
18,
ma'am. 18.
present, 18,
Yes, ma'am.
19, yeah, 19, 20,
Present,
21,
ma'am. 20.
20, 21,
Yes, ma'am. 21.
yeah, 21
Yes,
present.
ma'am. 21.
Oh yeah, 23, 23, 24, 25,
Ma'am,
26,
23. 23, ma'am.
okay, 23,
26 present. 26.
26, 27,
Ma'am, my
30,
network was so bad. So,
30,
Yes, ma'am.
30, okay, 31,
Yes, ma'am. 30.
31, okay, 31, 32, 32, 33, 34,
present, miss.
34,
Present.
36,
34.
okay, 36, 30,
Present, ma'am. 36 present.
37,
37 present, ma'am.
38,
Present, ma'am.
39, 42, 43,
43 present, ma'am.
42
okay,
present.
42 present, 43 present, 45,
Present, ma'am. 43.
Hello, ma'am. 39 present.
39, 46, 48,
Yes,
40,
ma'am, present.
49,
48.
45 present.
49,
49 present, ma'am. 49, ma'am, present.
oh, okay, 50,
Present, ma'am. 50.
Bravo, this year.
99, 101, 100,
Yes, ma'am. 99.
91,
What?
101,
Yes, ma'am. 101.
104,
Ma'am, 60 present.
Ma'am, roll number 51.
51. What?
Roll number 51 present.
57. 104. 57.
Ma'am,
Huh?
roll number 14 present, ma'am. Hello?
Oh, 14 present.
Oh, thank
104. 104. 106.
Present, ma'am.
106. 108.
Present, ma'am.
108.
108 present, ma'am.
Okay. 109.
108 present.
109 present, ma'am.
Okay. 111. 111. 113.
Present, ma'am. 130.
4.
Present, ma'am. 114.
Okay. 118. 118.
8 present, ma'am.
120. 124. 20. 124. 1, sorry, 1.
4 present, ma'am. 124 present, ma'am.
130. 133. Imasa.
Present, ma'am.
34, ma'am.
Huh?
Ma'am, 134 present, ma'am. 134.
34.
Ma'am, 33. 133.
3 present. 143. 44.
143. 143.
44. 45. 48. 49.
145.
150.
145 present.
Yes, given. 150. 151.
Present, ma'am.
151.
Present, ma'am.
Okay. Anybody left
Ma'am, roll
out?
number 51. Roll number 51.
51 given.
0505, ma'am. Sir.
0,
05.
5. 0,
Ma'am,
5
05
also
Ma'am,
given.
06060.
0, 6, 0 also given.
Number 039, ma'am.
0, 3, 9. Names
05
also
present, ma'am.
50.
present.
054.
0, 5,
Ma'am, 0
5, 0
0
given. Huh?
Ma'am, 054.
0, 5 given. Done?
Ma'am, 011.
0, 1, 0, 1, 1. Okay, present. Anyone else?
63.
Ma'am, 133.
133 given.
Ma'am, 063.
Present. Done? I'll just call out the names who are absent. Enrollment 2 absent, 7 absent, 9 absent, 19 absent, 24 absent, 25 absent, 27 absent,
Present.
24,
Yes, ma'am.
20, 25 absent, 27 absent, 31 absent, 32 absent, 46 absent, 52 absent, 55 absent, 57 absent, 58 absent, 59 absent, 61 absent, no, 104 absent, 136 absent, 144 absent, 148 absent, 149
Present,
absent.
ma'am.
Who?
136 present.
136.
Yes, ma'am.
Ma'am 009.
Okay. Okay, done. We'll start the class now.
Okay. Oh, oh,
Okay, ma'am, I saw 009, ma'am.
009 present. Yeah, I gave. Okay, last class where we were, eccentricity. We have done a solution on tendon, place at eccentricity. Okay, that was eccentricity. Did we go and talk about the bent tendon? We solved the problem on eccentricity. 39, 49, 48. Whoosh. Okay, I'll just share the screen. Where we were? This one we did we do this? Tendon place at eccentricity. Hello? Did we do this tendons place at eccentricity?
Yes, ma'am. We have done this one.
Okay, okay. Uh, have we solved this problem on eccentricity? When your tendon is here at an eccentricity, did we solve?
Ma'am, we saw last class.
This one? This one solved. Or I did in the other section. I think we have done this problem.
Yes, ma'am.
Did we do this? A pre-stress concrete beam method. No, the effective stress in the steel is 800. I think we have not done this. Maybe
Not done.
not done. No? Okay.
Not done, ma'am.
Okay. Okay. See now here this question. Hmm. This question, what is mentioned? A pre-stressed concrete beam 300 mm and 600 mm deep is pre-stressed using 5 high tension bars. 5 number of high tension bars are used which are of diameter 12 mm and they are provided at 220 mm from the soffit of the beam. The effective stress in the steel is 800 Newton per mm square. So the effective stress is given to us, but we are not provided with the this thing, a pre-stressing force. It is not provided to us, and we are asked that find the bending that must be applied to the section to just avoid tension at the soffit of the beam. That means we have to find out the bending. That means the bending moment we have to find out. M at the section to just avoid tension, and we know at the tension where it is the tension at the bottom, and soffit means from the bottom edge. Okay, so that means where to show here. If I show you, here, this is your beam given to you, and it is, you know, this thing, the section is given to you to be 300 and this depth is 600. Then we have 5 number of tension bars are used here. That means here you have 5 number of tension bars. Okay, not use both. So here if I use this pen only, here you have okay, this is your beam. This is your beam. You have the center here, and the tendons or the high tension bars are placed here. 5 numbers of bars are there. If you look the section here, if you look the section here, you will have your center somewhere here, and number of bars used is how much? 5. 1, 2, 3, 4, 5. 5 number of high tension bars of diameter 12 mm is provided to us, and at a distance of 220 mm from the soffit. That means from the soffit, this is your soffit bottom portion, and this is at a distance of, this distance is given to us, this distance is given to be 220, 220, and we know this distance, this total depth is how much here? 600, 600. This one was your 300 here. So since this is 600, this depth, this half portion from the center is how much? 300. That means your this portion till the soffit is how much? 300. 300. So now 300 minus your 220 will give you your eccentricity. This is your eccentricity. You will know your eccentricity value now, that how much is your tendons placed at how much distance from the center longitudinal centroid CG. This much, 330, 300, 300 minus your 220, that will give you your eccentricity. Now you are given an effective stress of 800 Newton per mm square. Effective stress, so you know the number of bars here, and the stress also you know, so you can find out the pre-stressing force. See for here now area you can find out from the section modulus, you know, BD square by 6. Section modulus is BD square by 6. Then you can find out the pre-stressing force to be 800, which is the effective stress. 800 into number of bars 5, and the area of the bar is pi d square by 4, which is pi diameter is 12 square. Okay, so this is your pre-stressing force, because you know your stress is what? Force per unit area, right? So your pre-stressing force will be how much? This effective stress into the area of the bars. And how many number of bars are there? 5 number of bars are there. So you got your pre-stressing force from the effective stress and the number of bars and the diameter of the bars which is provided to you. And eccentricity also you have calculated. 300 minus 220 will have your eccentricity to be 80. Now once you have your these things, we have to calculate what? We have to calculate the bending, that means the moment. We have to calculate the moment, and we know what is our stresses that are developed now at the midsection here. At the midsection, how much? P by A, that is the stress due to this pre-stressing force. Okay, this pre-stressing force due to this pre-stressing force P, and the stress due to this bending moment M by Z. Z we know, but now we can equate it and we can find out the this thing. You see here, if we consider this, and also there was eccentricity, so we had at the soffit was how much? P by A, P by A plus minus M by Z minus plus P E by Z. We had this total force, stresses which were on this particular beam now here. This one here, the stress due to this pre-stressing force, stress due to the bending moment, due to the load, due to this load. Then we have the due to this eccentricity, there is another moment which is minus plus PE by Z. Right. Due to this eccentricity, the moment will be in this way. That means negative at the top, and at the bottom we have compression. So, but in this question we are asked to find the bending. Just avoid the tension at the soffit of the beam. That means at the bottom portion. So at the bottom portion, we know what are our signs: P by A minus M by Z, which is this, plus your PE by Z, which is this, plus PE by Z. Now once we get this equation, we put the values in this equation, we can easily calculate our bending moment, which is this, 81.36 kilonewton meter. Okay, so in this way you can calculate your bending moments when you are asked with the effective stress etc. is given to you. Okay. Today we'll be talking, now next we'll be talking about this thing, the bending stress, the pre-stressing at the with the bend tendons. Okay, where is the, let me bring it, grab all this. Okay. Now where is the bend tendon? Okay, can you see my screen now? Pre-stress beam with bend tendons. Let me see this. See, these are your bend tendons. I cannot show. Okay. Now, sometimes what happens is that you will have bend tendons. That means earlier we were doing simple concentric tendons. Here either they were at the center or they were at an eccentricity here somewhere. But you also have, in some cases, you also have what? You will have tendons, bend tendons. Okay. And what are your bend tendons? These are your bend tendons here. Why? Because see here, is yeah. So now when you have a bend tendon, your bend tendons, by providing bend tendons, what you're doing, you are exerting an upward pressure here. Because see here, you will pull, you are going to, when you're doing pre-stressing in bend tendon, what you're going to do, you're going to pull your tendons. In this way you are going to give tension to your tendons, and then when you are going to release, what will happen, this pre-stressing forces are going to act here, and as a result of these two forces which are coming on your tendon here, Okay, what will happen? You are pulling this two, then when you are releasing, this forces are going to come, and due to these two forces, these are the components that let it consider that let we consider if we consider this is at an angle theta with the horizontal, what will happen? Here are some of the vertical and the horizontal components on both of this horizontal and vertical components. See, if this is your sine thetas and these are your cos thetas, what will happen here? Because we are providing the tendon, why this bend tendon? So that due to this pull, when you are having a pre-stressing force, this is going to give an upward pressure here, which is going to counterbalance this external load, point load here. So this is the load. Now W load, this load is how much, which is going to, in the band tendons there will always be pre-stressing upward stresses, upward thrust due to this bending. Okay, so now what is this bending? This bending is given by 2p sine theta. Why? Because there are two vertical components of force due to this precessing force. Here you will have two vertical components, which is sine theta. So 2p sine theta here. Okay, this figure will show you a precessing beam at the bend tendon. The effect or providing a bend tendon can be best considered by studying the concrete as a free body diagram. When you have a bend tendon, you will you will study the forces. How? By making it a free body diagram, because this is your external load here, this is your pre-stressing force at an angle theta, you have an upward pressure which is 2p sine theta. Okay, so now what will happen? We have to calculate the stresses, because here it is a kind of, actually when we are providing a bend tendon, that means we are actually trying to counterbalance this force. This is W and this upward thrust is 2p sine theta. So W minus 2p sine theta, when suppose this W is 10 kilonewton, 10 kilonewton, and this upward thrust is your 9 kilonewton. So this 9 kilonewton is trying to resist this 10 kilonewton load. So once obviously this will resist also. So 10 kilonewton minus your this 9 kilonewton, which it is able to resist this your beam due to this tendon. So now the leftover, what is your load that will be left out, which is acting on the beam, is 1 kilonewton, because 10 kilonewton minus your upward thrust, this is balancing, that means this is giving a opposite force to this load. So the leftover load will be how much, which is 1 kilonewton is acting now on your beam. So we have to find out the bending moment for this 1 kilonewton, because already the 9 kilonewton is already gone because of the upward thrust which it is giving to the load, which is developed by the bend tendon, okay, after giving the pre-stressing force. So if we consider this longitudinal axis, this force at the longitudinal axis is p cos theta, this one p cos theta. What will happen? We can consider it to be, here you see it, we can consider it to be p, because theta is very very small for us, that angle is very very small, negligible. So direct stress on this section will be how much? P cos theta by a, which is theta is already we know it is small, very very small, so it is p by a. Now what is your net bending moment? Net load will be how much? Actually, as I told you, the net load will be how much? This load, this downward load minus your upward load, whatever will be remaining is your net load, and due to this net load you are going to have a bending moment, and that is this. Now what will be your bending moment? Your moment will be for this point load. Point load, for point load what we have? WL by 4, and your W is how much? The left out W is your this W minus this, which is 1. So 1, actually it should be 1, because W minus 2p sin theta is your net load W, and your L is how much? Your L is the span of the beam, which is your not mentioned here, so it is the span of the beam, and we have WL by 4. Now another load, a bending moment will be there due to this dead load, which is the self weight of the beam. UDL, which is uniformly distributed. Now the bending moment due to this will be how much? WL square by 8 we know. So now the total moment is how much? The moment due to this point load as well as moment due to this UDL, the dead load. So what will be our extreme fiber stresses? P by A plus minus M by Z. Okay. So now if we go to a problem here, you see, this is your problem.
Ma'am, once again. Can you explain once again?
Okay. See here, there is nothing in a bend. Then what happens actually? Why we are bending this tendon? Because so that there is a balancing of the load. Okay. So when we do the pre-stressing here on the bend tendons will provide more upward thrust. Okay. Please mute your mic. Okay. So what? When you want more amount of force, then what you do, you bend your tendon so that that will give you your more thrust or more force back to your load. Suppose this is now when you are pulling these tendons, giving a pre-stressing here tension, and then you're releasing. What happened? This pre-stressing force will be developed here on the tendons, and these are your vertical components. This due to the force here, there will be vertical component here also, there will be vertical component and horizontal components will be there. Since these are at an angle considered to be at an angle theta with the horizontal, this your pre-stressing force at an angle theta, and also these tendons with the horizontal, it is considered or assumed to be theta. So now what will be the here in that center, which is going to give a force to this load, will be how much? 2p sine theta. This p sine theta and this p sine theta vertical components, they are going to act here together, and then they are going to resist this load. They are trying actually to balance the load. So that means if you have 100 kilonewton here, you have 100 kilonewton load W which is acting downward. Now when you are giving a pre-stressing force, what happens here? This is an upward thrust. This, suppose this is your 90 kilonewton. Okay. So due to this pre-stressing force, when we have given attention to your tendon and then again release, what happens? Compressive force is developed. Compressive force will act in this way here. So due to this, there will be an upward thrust of this tendon which will give a force to the downward force, so downward load. So that is 100. Since you have 100 downward load and your upward load is how much, which is giving a force back to your this load, is how much? 90. So 100 minus 90 is how much? The left out load, which is now the load which is acting on your beam is 10 kilonewton. Right. So now this 10 kilonewton is going to act on your beam after balancing the load to some extent. That means resisting or counterbalancing the load. Sometimes it may, we'll talk about the load balancing method later, when you completely try to neutralize the this thing, the loads. Okay. But here in this particular bend tendon, you are not completely this thing, your meeting is going to end in 5 minutes. Okay. You're not going to completely what? Equalize. Okay. Or balance. If we equalize, what will happen? 100 kilonewton minus, if this is also your 100 kilonewton, what happens? Your load will become zero. That means neutral. That means in your beam there is no load now. Okay. But in this particular case, we are having, after trying to balance, we have, suppose for an example, your upward thrust is 90 and your downward load is 100. So 100 minus 90 will be your 10 kilonewton now, which is your net load now, is acting on the beam. And you have to, and your bending moment which is occurring in the beam is due to this 10 kilonewton and not of 100 kilonewton now. Okay. So 10 kilonewton is what? Acting here now, bending moment. So we know what are the pre-stressing forces developed now on your beam due to this tendon is what? Here at the center is your stress due to this pre-stressing force, which is P by A, and stress due to this loads. How many loads are here now? Your point load is here and your UDL is here. UDL is the dead load of the beam. So what is your point load? WL by 4. The point load will be how much now? Which is 10 kilonewton left over. So that 10 kilonewton is acting here as a point load. So we are going to find out the bending moment of these point load, which is now 10 kilonewton. So WL by 4, you know your moment is how much? WL by 4 point for point load, and for UDL again another moment is there, which is WL square by 8, which is a UDL. So what happens is now this is your, there is nothing, no change, only what you have to calculate the stresses. So stresses are what? These are your stress, direct stress you already know from your pre-stressing force, and due to the bending moment of the different loadings, your stress due to bending moment will be there. So that is M plus minus M by Z, you know. And what is your M? M is nothing but the moment due to the UDL of the, that is the dead load, UDL, and the moment due to the point load. And what was your point load? Already I told you, if it is 10 kilonewton and your upward is supposed 9 kilonewton, so leftover is 1 kilonewton, and that 1 kilonewton is going to act now on your beam, and that is the load now, point load now. So that point load, you have to consider that point load after counterbalancing, and then you're going to take this moment. So it is W minus 2p sin theta, because your upward load is how much? 2p sin theta. You have to calculate your upward load, and that is given by 2p sin theta. Okay, and your L you know, 4 you know. So these are your stresses. Okay, fine. Done. Understood now? Next class we'll do a problem on this bend tendon. Okay, who was telling me to repeat?
Understood, ma'am.
Okay, good. I am JK. Okay, attendance I have taken. I think next class we'll do a problem on bend tendon, this kind of tendon. Okay. Where is my... Okay, so I think the meeting will end now. So we will meet in the next classes from 1 p.m. 1 p.m. we'll solve the problem on bend tendons. Okay, and if possible, if the time allows us, we will do the bend tendon with parabolic profile too. Okay. This roll number 38. 38 is the present. Okay, thank you. Long, thank you. Wabong Tamsin.
Thank you, ma'am.
Thank you, thank you. And 1 o'clock we'll meet, okay? So we can leave now. Otherwise,